Hello, everybody. So this is our video dealing with section 7, which is solving systems of equations algebraically. Now, the system that we're going to solve, I have an example here that we're going to cover. It looks kind of like this, okay? It's going to be in the form where we have, and this is the first equation. Right? There may be a coefficient multiplying x, coefficient multiplying y, and there is a number right here. And then some other coefficients. Okay, same thing. A coefficient multiplying x, a coefficient multiplying y, could be positive, could be negative, and then another number over there. Now, there are a couple of different techniques to solve these linear systems, but we're going to focus on the addition method because the addition method is the most important one, is the most efficient one. Before we even begin in attempting to solve this system, the way that we have to set it up them is exactly the way you see here. Okay, we're going to line up all of the x variables on top of each other. We're going to line up all of the y variables on top of each other and the numbers on the other side. Now, the system may not be given to us this way. Right? We may have something that looks like this, for example, or this. Maybe this is the system that we're given. So before we even begin to apply the concept of addition, which I'm going to describe shortly, we need to line up the x variables, the y variables, and the number exactly the way you see here. This is not the only way to do it, but this is the way that we normally explain to students, which is the easiest way. Okay? So for example, look at the first equation. The term with the 5y has to be on the left side. So I'm going to subtract 5y from both sides in the first equation, and I am going to get 2x minus 5y equals 3. So now this is properly set up. In the second equation, it seems like the 2y could come the other way, right? So I'm going to subtract 2y here and subtract 2y there. So they would cancel here. I'm going to end up with negative 4 equals 7x minus 2y. Okay. Now, obviously, this can be written over there. And now my system becomes 7x minus 2y equals negative 4. Now, as you can see here, the x's are lined up, the y's and the numbers on the other side. So this is where we would like to begin to solve the problem. So if the system is not already in standard form or proper form, we'll put it into this form before we begin. Okay, so this is step one. The next thing that we have to know is the following things. It's very important and we need to understand. Whichever method you solve a system like this one, a system of linear equations in two variables, we have to understand there's going to be three types of answers or three types of solutions. Okay? Number one, and we'll see all three. Number one, there's going to be a unique solution to the system. Now, that means you're going to find an x and you're going to find a y that solves the system. Meaning there's a point in the two lines where they intersect. This is the first solution, type of solution. The second type of solution is that there is no solution. Okay? That means that there is no x and y that solves the system. Now, how is that possible? Now, that's the possible because the two lines are parallel. They never touch. So if the two lines are parallel, They never touch. There is no solution to the system. So that's the second type of solution. And then the third type of solution is that there's infinitely many solutions. Now, in this case, the two lines are the same, meaning they're on top of each other. Okay, so if the two lines are the same, they're on top of each other, then there's infinitely many solutions. Okay, and I'm going to show you, this is the first one is the most important case that you have to be able to solve. The second and third cases may also appear. They're not as important, but we need to know how to handle them. Okay? All right, so that's the other thing that we need to know. And finally, the concept of the technique that we are covering, which is the addition method, is we are going to first line up the variables. Okay. Second, add the two equations. Add the two equations with the purpose of eliminating one variable. Okay. Our goal is going to be eliminate one variable through the addition process. Once we eliminate one variable, we can solve for the remaining variable. Okay. Solve the remaining equation. So the process is very simple. It usually doesn't take a whole lot of time to do this, and you see what I mean. So first, before even going into the problems that are in the workbook, I decided to put in a very, very simple problem here for us to do. And you see the concept. All right, so we look at the system. We need to solve the system of equations. First, we realize that the variables are all lined up, so this is good. Next, our goal is to add them, okay? With the goal of eliminating one variable in the process. So look at the system as we have right here and ask yourself, if I add these two equations, will one of the variables disappear? If so, which one? And you can see if I add them, yes, I will have one cancellation, and the variable that's being canceled is y. So let's add them. So if I add x plus x, I get 2x. If I add positive 1y and negative 1y, they cancel, which is what I want. 7 plus 1, 8. Now, this is always going to happen. Once you eliminate one variable, you're going to end up with something extremely simple that we can solve for the remaining variable. In this case, the only thing I have to do is divide by 2. And I get x equals 4. Okay, so I already got one solution. I need to find the value of the other variable. This is what it means to solve the system of equations. Once I have one variable, you can go back into either equation, the first or the second, to find y. Okay? I am going to use the first. So find y. X plus y equals 7, but I already know x. So 4 plus y equals 7. And then just subtract 3 on both sides. Uh, subtract 4 on both sides, I'm sorry. Subtract 4 on both sides, and I get y equals 3. So in this case, I got a solution that x is, my pair is 4, 3. Now, this is the case of the unique solution because I got a single point. So the two lines intersect at x equals 4, y equals 3. Now, if you wanted to check to see if this is correct, okay, you don't have to check, but if you do, and I'm only going to do this once for the purposes of illustrating how to check and not making the video very much longer than it's going to be, okay? All you have to do is replace the values that you found for x and y into the original equations, both of them. And they obviously both have to match. So first equation, x plus y. So 4 plus 3 equals 7. That checks. Second equation, 4 minus 3 equals 1. Yes, that also checks. If both equations pass the test, meaning the left side equals the right side, that means that the solution you got or you found is correct. This is the check. All right. So this is the technique for uh, solving the systems of equations by the addition method. Now, obviously, this example was extremely easy, and we're going to do a couple more that are more realistic or of what you can expect for unique solutions. So these two are very good examples. We're going to do these two examples to show you how a normal system looks like. Okay. So here's system one, problem 7.2. Now, first you realize that the variables are already lined up. This is good. And then if you try to add them as they are, ask yourself, will one of the variables disappear, be eliminated? And in this case, the answer is no, right? So if I add the 5y to the negative 2y, I get 3y. If I add the negative 3x plus 9x, I get 6x. So nothing disappears, nothing cancels. So in that case, if you try to add them and nothing cancels, then you're going to have to multiply one equation or the other equation or both by a different number so that after you multiply them and add them, one of the variables will disappear. So notice that in this case, because 9 is a multiple of 3, it is easy if I multiply the first equation by 3 to cancel x. Look what happens. Now, when we multiply one equation by a number, you multiply every single term. So I'm going to get negative 9x plus 15y equals, what is that, 57? So multiply the entire first equation by 3. Don't change the second equation. All right. Now, notice if I try to add them now, x will get canceled, which is what we want. Out 13y, and this is 65. And now it's similar to what we had before. I have a very simple equation to solve. I'm going to divide everything by 13. And I'm going to get y equals 5. So the addition method is extremely fast and usually takes, after you multiply one equation or the other, the answer comes out very, very fast. Once I have this solution, I can go back into either of the two original equations and find the other variable. So I look at this and I say, which one is easier for me to use? Well, I don't know. Maybe I can use the first one. You can use the second. So find x. I'm going to use the first equation. And you're going to replace y with the value that you found, which happens to be 5. Okay, so I have negative 3x, 25, 19. And I am going to subtract 25 in both on both sides because I have to isolate the variable. So negative this, and this is negative 6. And we divide everything by negative 3, and we get x equals 2. Now remember, negative divided by negative is a positive, 6 divided by 3, 2. So my solution in this case is 2 comma 5. Okay. So again, a unique solution. All right. So this is the first case. We had to multiply one equation by a number to proceed. Now let's do the second case. I'm going to erase this thing so I can use the area here. Now, same thing with the second problem, 7.5. I look at these two equations. I first realize that they already lined up, x, y, and number, so that's good. And I try to add them as they are. If I add them as they are, I will get negative x, positive 3y, which is not what I want. I need to have, after the addition, one of the variables cancel or disappear. So I have to do something, okay? So I have to look at this thing and I have to decide which variable I can cancel. Now, because the coefficients of x are smaller, I'm going to focus into canceling x. But in this case, the negative 3 and 2 are what we call relatively prime. So I would have to multiply the first equation by 2 and the second equation by 3 in order to cancel them through the addition method. So let's see what we have. So multiply the first equation by the entire first equation by 2. So negative 6x plus 20y, 50. Now multiply the second equation by 3. 6x minus 21y minus 54. Okay, and now notice, if I add them now, right, the x's will cancel. And that's the purpose of these two numbers. You could cancel either the x or the y. In this case, I decided that it was easier to cancel the x because the coefficients were smaller. So 20y minus 21y minus 1y, 50 minus 54 minus 4. And we just divide everything by negative 1. And we get negative divided by negative positive, 4 divided by 4. So I found one answer. Now I go back into either of the first two. You could use the other two that you found, but there is no point because these are going to be smaller coefficients. And I'm going to use the second equation to find x. Minus 7y, negative 18. So we're going to replace y with the value 4 right here. We're going to add 28 to both sides because we have to isolate the variable. 28 minus 18. And we're going to divide everything by 2. And again, I have a unique solution, x equals 5, y equals 4. Again, remember, if you wanted to check, you get the x equals 5, y equals 4, and you're going to replace them into the system to confirm that the right side is 25, and the right side for the second equation is negative 18. I'm not doing this thing right now because I wanted to make the video a little bit shorter. But that's it. So these two examples are examples, very good examples of the unique solution, where in the first case, we had to multiply one equation by one number. And in the second case, we needed to multiply both equations by a different number. So that may happen. Okay, so these are the unique solution cases. Now let's see the cases that are not so common because they are exceptions, okay? But they may still come up. So Problem 7.8. So let's take a look at the equations again. They're already lined up, which is nice. And if I add them as they are, the x's will be 20x and the y's will be 16y. So that doesn't help. So I'm going to have to multiply one equation by a number to cancel one of the two. So I'm going to decide to cancel the y. Okay. To cancel the y, I'm going to multiply the second equation by -3. Now look what I'm going to get. Don't change the first equation, but the second equation becomes 5 times -3, -15. 4y times -3, -12y. And 3 times -3, -9. Now I can add them. But when I add them, the x's cancel, which is great, but the y's also cancel. So on the left side of the equation, I end up with 0. And I have 10 minus 9, which is 1. Now, you may get something like this, okay? You may get a number which is 0 equals something else. Now, this is a false statement, right? Now, if you get something like this, 0 equals any other number, that means that the lines are parallel. And you have to write on the exam, no solution. This is a case where you have no solution. The lines are parallel. They never touch. And this case, it's always going to be 0 equals some other number. Always 0 here. Always 0. Okay? So this is the no solution case. And you have to write this on the exam, no solution. Because otherwise we don't know if you know that this is a no solution case. All right, so this is case number 1. The other case that is something that may show up is this case. Same as before, I look into the system, the variables already lined up. If I add them as they are, I'm going to get 16x and 12y. So I'm going to have to multiply the first equation by -3. Again. So let's see what we get. Don't touch the second equation. So just leave it as it is. Multiply everything in the first equation by -3. So -12x, -9y, -3. And now I can add. But the x's cancel, the y's cancel, and -3 plus 3 is 0. So if you get 0 equals 0, this is a true statement. You have to write infinite, and you have to write this, okay? Infinite solutions. Now, why is that? Because the lines are the same. Look what we got, right? Isn't it the same line? -12x minus 9y equals -3, and the same thing over there. Well, professor, but they're off by a minus. Yes, I know. But if you multiply the first equation by -1, you get 12x, which is this, positive 99, which is this, and 3, which is that. So it's the exact same equation. Okay, so if you get 0 equals 0, you write infinite solutions. If you get 0 equals any other number, this is a no solution. Okay? So this is how you solve these systems of equations with the 3 possible cases: unique solution, no solution, and infinite solutions.